Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 27th of June, 2025, T 17 hours, 59 minutes, and 27 seconds, .000Z. This paper, published just a few days ago, introduces a new model that actually outperforms GPT-4o on a key multi-image reasoning benchmark. The paper is titled MiCo, Multi-Image Contrast for Reinforcement Visual Reasoning. And the really interesting part is how it achieves this without relying on any human annotated question-answer pairs. So the authors developed a self-supervised method that trains a model to reason by simply comparing very similar images and figuring out what's the same or different. So to really see the problem in action, the authors show a set of examples. The first is straightforward, counting a person across different scenes, which current vision language models, or VLMs, handle just fine. A vision language model is an AI that can process both images and text together. But the other examples are much trickier. They involve spotting subtle differences between toy cars, or even noticing a label on a cage has changed. On these tasks, even strong models like GPT-4o fail, showing a clear need for better comparative reasoning. So to solve this, the authors created a clever, self-supervised training method, which we can see here. They build these image triplets, basically sets of 3 images. The first 2 are slightly different versions of the same scene, and the third is a similar but distinct image. The model is then trained to generate a reasoning process, what the authors call a chain of thought, to figure out if a pair is the same or different. This forces the model to notice tiny details, like a different couch or a changed rock climbing hold, without needing any human-written labels. Alright, moving to the results. This table really shows the payoff of that training strategy. It details performance on the VLM2 bench, which is a benchmark, a standardized test, specifically designed to evaluate how well models can link subtle details across multiple images. And the results are pretty striking. The new model, MiCo 7B-COT, achieves an overall accuracy of 61.06%. This actually sets a new state-of-the-art, edging out even powerful models like GPT-4o, which scored 60.36%. It's a powerful demonstration of what this self-supervised method can do. Building on those impressive benchmark scores, this figure gives us a more qualitative look at what's happening under the hood. It shows 4 examples of the model's reasoning process, its chain of thought in action. For each question, like counting different cups or figuring out how a camera moved, MiCo first breaks down the visual evidence in each image. Then, it performs a cross-image comparison to arrive at the final answer. You can see it meticulously pointing out differences in cup designs or oven doors, a detailed logic that the training method was designed to encourage. So to wrap things up, we've seen how this model learns to perform complex reasoning. The key takeaway is that by using a clever, self-supervised method, specifically contrastive learning, where a model learns by comparing similar and different items, it can teach itself to spot fine-grained details. This approach, which avoids the need for expensive human annotated data, allows the model to build a logical chain of thought and ultimately outperform even top-tier models like GPT-4o on specific multi-image reasoning tasks. That's all for today's AI Research Roundup. I'm Alex, thanks for tuning in.